dear students, welcome back to the session. In this session, let us understand the question answers from the lesson periodic classification of elements. This is the continuation of the last session. So the next question is, what property do all the elements in the same column of the periodic table as boron have in common? Very simple. If you look at the periodic table, where is boron present? It is present in the 13th group, correct? So, and the atomic number of boron is 5 and its electronic configuration is 2, 3. Here, the boron is having 3 valence electrons, whereas the other elements in this group are also having 3 valence electrons on their outermost shell. So other elements like aluminium, gallium, indium, titanium, whichever the elements which are present in the 13th group are having same number of valence electrons on their outermost shell. Similarly, the boron also is having the common. Clear? And the next question is, what property do all the elements in the same column of the periodic table as fluorine have in common? If you look at the fluorine, where is fluorine present? It is present in the 17th group, correct? Fluorine is present in the 17th group. So, if you look at the fluorine's atomic number, the atomic number of fluorine is 9. The atomic number of fluorine is 9 and its electronic configuration is 2, 7. And if we also observe the other elements which are present in this group, like chlorine, bromine, iodine, all these elements are having 7 valence electrons on their outermost shell and their valency is 1. What is valence is 1? They require 1 electron to fulfill their outermost orbit. They have 7 valence electron, they need 1 more electron to fulfill their outermost orbit. Correct? Similarly, the fluorine have the common property of the other elements which are having in this group. Clear? And the next question is, an atom is having the electronic configuration of 287. What is the atomic number of that element? An atom is having the electronic configuration of 287. Very simple. How to identify the element? Just add this electronic configuration. You will get a sum of 17. Now the atomic number is 17. So look at the periodic table, which is the 17th element. It is chlorine and the element is chlorine. Clear? To which of the following elements would it be chemically similar? That means if you look at the electronic configuration of 287, among nitrogen, fluorine, phosphorus and argon, which elements are having similar number of valence electrons on their outermost shell? Look at nitrogen. What is the electronic configuration of nitrogen? It is 2, 5. Fluorine 2, 7. Why? Because the nitrogen is having the atomic number 7, fluorine is having 9. What about phosphorus? It is 2, 8, 5. Correct? Argon 2, 8, 8. Now look at all the 4 elements which is having the similar chemical property. You can look at now the fluorine. Fluorine is having 7 electrons on their outermost orbit. Similarly, the element chlorine is also having 7 electrons on their outermost orbit. Now the answer is, to which of the following elements would it be chemically similar? It is chemically similar to fluorine. Fluorine and the chlorine are having 7 electrons on their outermost orbit. It is very simple. Again, if you look at the fluorine and chlorine, they are also present in the same group. Clear? The next question is, the position of 3 elements A, B, C. The position of 3 elements A, B, C in the periodic table are as follows. That is, we have to look at now the group 16, which is the 16th group. This is 16th group and 17th group. We have to just concentrate on these 2 groups. So if we look at these 2 groups, 16th group and 17th group, okay, here there are 3 elements, that is element A, B, C. The question is, state whether A is a metal or a non-metal. See, you know that if we look at the periodic table, 16th group and 17th group, they are present on the right hand side of the periodic table. Correct? And the elements which are present on the right hand side of the periodic table are non-metals. Correct? So now element A is a non-metal because it is present on the right hand side of the periodic table. It is in the group 17, hence it is a non-metal. Clear? The next question, state whether C is more reactive or less reactive than A. So there are two elements, that is element A and element C. Among these two, state whether C is more reactive or less reactive than A. We have to look at with respect to A whether C is more reactive or less reactive. Now, if we look at the periodic table, just consider the element may be the chlorine and bromine. Just assume the element may be the chlorine and which is the other element we have seen below the chlorine, it is the bromine, that is 35, correct? So if the element chlorine is having the atomic number 17 and bromine is having the atomic number 35. So now look at the element. If consider element A as chlorine, element C as bromine. Okay. So now both are belonging to the 17th group and both are non-metals. And as element C is below the element A, that is bromine is below chlorine, as element C is below the element A, you can see the atomic number is more. Which is having more atomic number? Bromine is having more atomic number than chlorine. Correct? And if we compare the element A and C in this group, we know that as we go down the group, the metallic character decreases. Correct? As we go down the group, the metallic character decreases. So, C is less reactive. I repeat, as we go down the group, the metallic character decreases. So, C is less reactive. Now, if they ask bromine, for example, bromine is less reactive. Why? Because if we go down the group, what happens? The attraction between the nucleus, as the number of shells increases, the attraction between the nucleus and the outermost electron decreases. As the attraction decreases, what happens? It will be less non-metallic. It will be more metallic, that is metallic character decreases, and the non-metallic character will be increases. Clear? And the next question is, will C be larger and smaller in size than B? They are asking, will this C, the element C, will be larger or smaller than the element B? Now if we look at the element B and C, they will be present in the same period. Correct? And you know that elements present in the same period are having the same number of shells. For example, if you look at this period, second period, the elements present in the second periods are having same number of shell, but the number of electron keep on increasing. Lithium is having 2, 1, then 2, 2, 2, 3. It is so on, right? 2, 4, 5, 6, 7 and 8. It increases, but the number of shells remains same. I repeat, the number of shells remains same in the period. So the question is, will C will be the larger or smaller in size? If B comes first and C comes next, what happen? Suppose B is having 2, 1 and C will be 2, 2, then what happen? The number of electrons on C shell is more. If the number of electrons is more on the C shell, what happen? The attraction between the nucleus and the outermost electron increases. So the size of B is larger compared to C. So the size of C is smaller. It is smaller than B. Correct? Size of the C is smaller than B. Clear? Next, which type of ion, a cation or anion, will be formed by element A? Since element A is a non-metal, we know that group 17 elements are non-metal. Since element A is a non-metal, all the non-metal will accept the electrons, means they require electron from the other elements. They take electrons from the other elements, correct? And A becomes A minus. That is nothing but A minus, nothing but anion. That is negatively charged. It is negatively charged element. Clear? So which type of ion, a cation or anion, will be formed by an element A? It will form a anion because it takes the electrons from the other element in spite of donating. Clear?